All right. And we are live now, sir.
Hello, yes, we are. Can you hear me?
Yeah, we can hear you. We can
Cool.
hear you.
All right, so let's get this started, Vishwas.
Sure, then. So, hey, folks, this is me, Vishwas Narayan. I'm not the host of this show, but today we are starting out a new series, and we had to become the host because to me, data engineering has been something that I call myself as a cloud champ these days. But to me, the definition of it started when we saw and data making an impact in a huge agenda. Like it's a huge agenda for me tomorrow as well. So now, what do we do with the big data technology? What do we do with whatever is getting improvised every single day? And I'm with Akash, who's just going to just not just going to give you an insight about what is data engineering for 2023, but this is going to be an introduction where data engineering is going to be talked in terms of the modern world, like what should be our approach. And there's a lot of things that we are about to discuss in this series. And over to you, Akash, sir. You can give your introduction.
Hey, hi, folks. This is Akash Sharma. I am partnering today with Vishwas, and we are going to be talking about data engineering. Now, I've been doing data engineering well, in a different name for almost the entirety of my career. We used to call it ETL in good old days, and now the more popular word data engineering. Now, the tools have obviously changed, but I think the fundamentals have fortunately remained intact. The principles, practices have evolved certainly, and with the advent of machine learning, you have a completely new flavor to data engineering. So we are going to be talking about what data engineering is, the roadmap, and what are the some of the trends that we see. Vishwas, I believe, is going to do doodling. Is that right? Am I calling it right?
That's true. That's true.
So we are going to be having a conversation, as well as he's trying to give a picture to what I say. So I'm looking forward to the process because this is new for me, and we both are collaborating for the first time. So do check his channel out. What's your channel?
Vishwas Narayan. So it's by
Vishwas
my own
Nara.
name.
So his name is his channel. Do check it out on YouTube. Obviously, if you're on LinkedIn, you will follow him or well connect with him. If you are looking to follow me, my channel is Cafe.io. I am with my name Akash Sharma on LinkedIn. Do find us to reach us, and we'll be happy to talk to you. Let's get this started. Over to you,
Sure,
Vishwas.
then. Sure. Let's start with it. Like, how is the future of data engineering going to be defined by today's process that we are talking? Because
Okay,
whatever we
sure.
thought back then as an ETL, today it's just new form of tool, new form of software. So how is it evolving over a course of time?
So I think let's say that necessity is the mother of invention, right? Uh, for the past about 5 to 6 years, industry has had very uh, crazy trends. There has been highs, which are pure hypes created out of technology like machine learning jumping in the world and trying to take the world by storm. And then COVID hit, right? And everything, including IT, has to let's say nimble down or humble down itself. And then again, people are trying to double down on the technologies that they started pre-COVID, and machine learning is one of the key areas. Now what has happened with that is there is a very new focus on data. Traditionally, IT systems were transactional in nature, and analytics was a second part of it. Once the transactions is completed, once you have the web app, the mobile app, then people will think about analytics, and then there'll be a data strategy. Good old days, we had data warehouses. We still do, right? But now, with AI being driving a lot of strategy in different organizations, data engineering is getting a front seat. What is happening is that more and more people are realizing that they need to pay much more closer attention to the data if they want to generate analytics and revenue. So data engineering is sitting at the forefront, and this has been happening for the past few years, so much so that you see new trends like there's trends in the way people select their databases. uh, when I started my career about 10, 11 years back, Oracle was the leader. Now you see a lot of open source players in the market, and within a period of 10 years this has changed. There's different types of databases out there, there's different types of tooling out there. There's low code, no code, there's event driven. So these patterns are what we want to talk about today, and let's see where we go. So Vishwas, should we start up the diagramming process? You are not audible. You are on mute.
All right. So yeah. So the first thing is it's always about where does the team need to spend a lot of time. So now you told about if you can share my screen, you just said trends to select a database, trends to analyze data, low code, no code, event driven. So where is this technology going to take us over a course of time?
I think these are uh, concepts or constructs of uh, the same tree. Let's think of them as trunks of the tree. So when you say select the database, that is driven by the fact that how what kind of data you need to store. When you say low code, no code, that is driven by the transformations and your team's capability to handle transformations. When you say event driven, that goes back to the source and says, hey, how this data was generated. It also talks about some aspects of the data. For example, the speed, right? If it is event driven, it's going to be high speed. So let's take that thread for example. So what is event driven? Let's take cricket, right? India loves cricket, and we'll talk about cricket. So you have IPL going on, right? There's, or I don't know if it's going on or not. I'm sorry, I don't follow cricket, but uh, let's just say you have sports data and cricket is happening. So you have a lot of data generated really, really fast. Once a ball is hit or once a player makes a century, you suddenly see plethora of charts, right? You see that the player has been able to beat some 20-year-old record, has this ball had the fastest or falls was the top sixth ball of the over, or I don't know, tons of different kinds of analytics in a very fast. What I mean to say is that there is data generated that is very fast, and analytics also is very fast. So in order to build that system, there'll be a different kind of behavior, and for that you'll apply a certain different kind of technology. Now let's say if I was in a manufacturing setup where I'm gathering the same data and I'm collecting data from manufacturing plants, IoT, but I don't need to analyze them every single second, right? I probably just need to see when they go wrong. Let's say there is manufacturing plants. Let's say there's a humidifier which generates heat and steam across certain time period. You're getting that data, right? You're getting that data, but you don't want to see every single second what's happening, right? The needle. You just want to know when it's not performing what it should be. So that's event driven, but analytics is not real time. So driven by the behavior of the data and the need to understand the data, or let's say generate analytics, other decisions get impacted. Now the way you store the data, low code, no code, all of these are attributes of that. So that's how I think of it. It's one single tree, and then there's tentacles coming out, and this connected. So the best way I would think would be in the form of a graph, right? You can think of these as hubs and connections and that kind, if that's making sense to you. You're able
All
to follow
right.
through?
Yeah, yeah. I think the whole process of being in data engineering and taking something event driven is we need the performance of an event driven matrix, and we should also learn to automate the process that is just being taken care. Automate the process of an event. That means if there is an IoT sensor that is coming up into the cluster or else any node which is actually driving the data in and out of the system has to analyze, automate it, and if there is an error, of course, there is obviously a need for it. But there are a lot of services that are coming up. Like the moment you think Apache Spark, pro- like literally automated most of the process, considering the data which was supposed to be batched out there, or else the data which was supposed to be bucketed out there. So how has that world evolved over a course of time? That means there is
So
obviously there is DAS and all that frameworks which are coming up. So how is that framework going to be there in the world today?
let's talk about Spark, right? I'll ask you to open something. Can you open Spark architecture? Just Google Spark architecture high level. There's or
All
Spark
right.
components. This four
Yeah.
five box. No, no. Go to images. I'll tell you which one. Yes, the third one. The
The third
fourth
one?
one. Yeah, go up, go up.
Is this the
Yeah, let's just see what. Yes, this one, the one that you have. So I it's okay. I think I can understand this. Yes, this is what I want you to stop right at. Now, if you think and if you pay very close attention to, most people associate Spark, and I don't mean to get deep into Spark and make this a Spark conversation, but I want to start off with something very important. When people think of event driven, they think of Spark. But if you see what Spark stood for, Spark was actually a framework which unified batch processing and real time processing. So there's a concept called Lambda architecture where you have batch and streaming in your
thing?
system at the same time, right? Spark, I wouldn't say, let's say, pioneered, but Spark laid out in a very nice way that whole architecture. And while people naturally think of Spark to be the framework for event processing, I think it's amazing for batch processing as well. That's where it really shines. So if you take a look at Spark architecture, there's frameworks to handle both. And then Spark by design, I think Spark could be in itself a case study as to how good technologies are designed. It has a good batch processing engine. It has a great real-time processing engine. It has a streaming engine. It has a machine learning library. It has a graph computation. And on top of it, even after being so powerful, they have respected SQL, where they have given interactive querying capability within Spark to handle and work hand in hand with its other components of the Spark. So Spark query language, the Spark interactive queries, they work very nicely with space streaming engine. So I would say that Spark has been there. There's a couple of parallels in the space, but what Spark does at an enterprise level, I don't personally know of a lot of competition to it. Yes, there's frameworks like
Hmm.
there was a very interesting framework. I'll just give me a second. I'll search and tell you.
Got it.
It's called, I think, Sphinx. No,
Flink?
Flink. Yes, Flink. Flink.
Flink, yeah.
I tried dabbling with Flink like 2 years back or maybe a year back. It was good. It's good, but I think the kind of problem it solves is very compact, or I would say very well defined, and it's not a drop in replacement for Spark. Now, Spark was already good, and Databricks as a company has taken them further. So, Spark
Hmm.
is very much good from an open source standpoint, very good from an enterprise standpoint. So, I would give if somebody is starting their career in 2023, learning Spark would be great. I think
Hmm.
there is still a couple of years to go for Spark, and I don't see it. I don't know if it's at a peak or not, but it's certainly not dropping. There are more cutting edge
Hmm.
technologies, there always will be, but you have to understand that most technologies that are cutting edge don't make it to the industrial and enterprise level. Spark is one of those technologies that has successfully reached that level. So if you are starting your career, uh, sure, starts with Spark, go to a great deep dive into Spark, learn the fundamentals, learn the infrastructure as well, understand how parallelization works in Spark, understand the notions of distributed acyclic graphs, understand how graph manages the computations, and try to play with some core use cases in Spark if you can. I think Spark tuning is itself an interesting area. If you really like that kind of a work, but that's very hardcore. What I mean by
Hmm.
Spark tuning is, let's try to take an example. So let's say you have a machine learning job and you submit it without realizing whether it's where it's gonna run. It could typically just by default to the master node, but you
Hmm.
want it to go on worker node. Now figuring this out, what has happened to your computation is not a straightforward exercise. You should know the nuances of Spark architecture and infrastructure to be able to debug this scenario. So yeah, if you're starting, do start with Spark. Great data engineering, good career move. A good combination with Spark would be Snowflake. I think that's another database which on rise, but you can, for that matter, master any. I would say data platform. RDS is great. Postgres is great. Spark, and you can actually work with big data too, and have Hadoop ecosystem support Spark, and they go like good siblings. So yeah,
Yeah,
that's what I'll say on Spark.
I think Snowflakes has been one place where everybody really goes behind. But let's talk about it. We talked about Spark. We also talked about how event-driven, low-code, no-code, and all these have an impact. But where will the teams spend more time? Because back then, when I started in 2017, writing an dog versus the cat model was something which was more good. But now today, it's everybody can do that.
I think teams will spend a lot of time in optimizing for cost now. The FinOps conversation will either
Hmm.
should have started, or they really should start talking about it. Now, what has been happening for the past few years is there's different data trends popping up, right? People had the notion of data
Hmm.
warehouse, data lake. Now there's mesh, there's centralized, decentralized, hybrid, all sorts of patterns floating around. And on top of that, you have a very nice setup of cloud databases, things like RDS, Postgres, Snowflake. There's tons of different databases. And then there's a lot of specialized databases out there coming out there. Yeah, I am missing some of them. There's one in big data ecosystem which is very popular, Cassandra. Cassandra is huge.
Cassandra.
Some of the logging frameworks and tool use databases, Elasticsearch, Logstash. That's a very nice stack to look at from a data store and complexity perspective. But fundamentally, going back to your question about where do teams most spend time in, so the way the economic environment is that storage is cheap. Everybody knows that.
Hmm.
Everybody has known this for a long time, right? Compute is still costly comparatively. So what happens with these modern cloud platforms is that when you look up the size, for example, let's take an S3 bucket, right? You would probably think that the cost per GB is very low. And when you want to start estimating, you'll think, hey, I just have 10 GB a month, and let's say 10 GB cost $1, for example. So you'll say, okay, 10 GB, 10 GB, 10 GB every month, and I'll, $12. But what you have failed to understand is that the cost is cumulative. If in the
Hmm.
first month you have done 10 GB, that's going to stay for 12 months. So at the end of 12th month, you have the first month data and all piling up. So in the 12th month, you have 12 months worth of data. So that's 12 GB of data, or 1200, whatever is the unit you're taking. And when you run queries on that, these are exponentially costly. What I mean by that is running query on a smaller data set might be very cheap. But as you have used the same query, most people wouldn't go to the point of optimizing their queries, adding more indexes, chopping them, partitioning their data, all the good things we used to talk about in the old days. But they would not do cost optimization. So they would probably just continue that the system is scaling as they throw more infrastructure at it, which is a very bad practice. So the cost optimization, in my view, is going to be an increasingly important avenue for most companies. And I think even the cloud vendors are aware of it. So data cloud vendors and data warehouse and lakehouse vendors, they are very much aware of it. But and they want the consumption to increase. They would, like Snowflake would definitely want more people to join Snowflake, right? But a lot of waste would lead to customer churn, which is to say that if you start on some cloud data platform and you are incrementally increasing the cost, sooner or later the customer would want to go away. So both product teams as well as data platform technology teams. Both of them are increasingly aware of this problem, and they are trying to do the cost optimization. So this
Hmm.
is, I think, going to be really, really important for teams going further.
That's true. That's true. I think whatever we have, it's not just Delta just being gold tar, silver tar, or bronze tar. There's obviously a different definition out there that is coming up in the market. So it's. I always say this. Always, there is a saying in big data: you always get your compute to the data instead of getting data to the compute. There is obviously a cost that is getting reduced because of the transaction and things like that. But what are the specializations that they need to think? Like, there is an hub and spoke model. There is obviously a new way in which
Sure.
we architect a solution. So, what are the
I
new ways
think,
in which they need to prioritize the new things that they want to learn today?
sure. I think there's two sides to this. One is uh, the architecture of the team, the team structure itself. So the teams will also get more specialized. What I mean by that is you will have data engineer who specialize in ingestion, who specialize in high
Hmm.
speed ingestion. There will be analytical engineers who specialize in cleaning the data, right? There will be data engineers who are, let's say, let's call them data project product managers, because product roles are also evolving, right? There's
Hmm.
finance product owners, so there'll be data product owners who will focus on the visualization of the data. So
Hmm.
there'll be roles which are very deep and more, I would say, carved out of existing larger broader roles into data engineering specific role. Data engineering is already a specialization, but within data engineering you could have more specialized data engineer into a variety of different roles. That's one part. The second part is, which I was speaking before, right? You have people still value data warehouses. I don't think personally they will go away. I could be wrong, happy to be proven wrong. Uh, and then there's the concept of data lake as well. So warehouse is build specialized, lake is tangentially opposite direction, build generic, right? Now, I think people have realized that there isn't one size fits all. So taking one approach isn't the success criteria for an organization that ये ले लिया and इससे तो दुकान चल पड़ेगी boss. ऐसा नहीं हो रहा है. That's not what is happening.
Hmm.
So companies are having centralized data lakes, which is kind of a platform for other teams to take, and then there's domain specific data warehouses built of that. So we call that hub and spoke model, or the COE. Now, there could be fully distributed also, which is loosely saying data warehouse, but they are powered by the platform, which is Snowflake. So, for example, Snowflake might have be the underlying platform, but then different databases for different product teams, or different teams like sales, customer, procurement, planning, supply chain, warehousing, demand planning, etc., etc. All of that, tons of that, different kind of databases. So different variety of those models are also popping up, which I think teams will need to spend a lot of time into thinking about how to manage.
All
Uh,
right.
yeah,
But is it better to have an orchestrator here rather than just complicating the already rigged up stuff like domain one, domain two, domain three as different ownerships? I think
I
different
don't
ownerships
I don't know.
as
It could
an
be it's very case dependent, right? It could be given an organization is what the needs are will typically drive this conversation. There isn't a one shoe or one socks fits all kind of a thing.
yeah. So
Yeah,
I think you talked about platforms as one of the key roles in which data teams can already have different people coming up. So if you can consider this as an hub and spoke kind of a model where there's one kind of an engineer who just comes out there and brainstorms to how hundreds of different problem statements that are already there today. But don't you think that hub and spoke makes a huge mistake when it comes to
Not
keeping one person
really.
as an owner who is just taking care of one?
No, see, what you're talking of is, look, I'll give a philosophical answer to this. Whether a democratic
Mm,
situation is bad or whether a monarch situation is bad, both of them can be good, neither of them can be good. It really depends on how
mm,
the democracy is implemented and how the monarchy is implemented. People used to love kings. I think there are countries in the world where still there are kings, and well, the countries are doing good. So you cannot debate that that's one model which will not work. So having a single owner does solve some problem, creates some. Having distributed ownership solves some problem, creates some. Now it just is a matter of conversation, what problems or what, let's say, options are more important for you, and how do you want to balance them in the scales.
sure. I think that's a pretty good answer. So now let's go back to, there is always a conspiracy that 85% of the models don't go to the production and things like that. But there's obviously an urge for any developers to go out there and adopt anything early and easy as quick as possible. Like they want to make sure the platform has less complexity and the engineers have less complexity to deal with. So now let's go on with how data contrast to move to an early stage adoption is going to be more feasible and more appreciable when we consider the process that we have right now. So the data contrast that we are talking these days.
Okay, so I think the first part what you said, the percentage of machine learning model making into production are becoming more. Why I feel that is because the world is talking about MLOps more. So naturally, when things get to production is when people want to talk about operationalization. So I think there is an evolution there. It's no longer that 80% of the models or 90% of the models don't go to prod. Models are making it to prod, and people are now asking the right questions, whether is this model the right model for me? Is this model some kind of, giving the business value? Is this model decaying and all of those good stuff? So I think people are talking about that, and hence the percentage of models making into production is more. Now to talk about the second part of what you asked, right? Data contracts, right? So data contracts are going to be helpful. Now, why would they be helpful? Because one of the biggest problems for, and this is not a new problem, by the way. This has always been a problem, and I think this will always remain a problem. Schema changes are not good.
Hmm.
Schema changes are not good. Write that down, tattoo it out if you're a data engineer. If you can avoid schema changes, or let's say if you can plan for handling schema changes, because I don't think you can avoid them, uh, because they constitute a large chunk of portion of data quality issues, right? So let's give an example. A lot of data is today in the form of web services, event driven, and there's JSONs getting thrown everywhere around. Everybody loves JSON. They are the favorite poster child of a data format. Human readable, machine understandable, transmittable into nice chunks, very low loss, can handle most types of data. HTTP2 supported. I think it supports HTTP 3.2. I'm not sure if that's true. Great from a security standpoint. So everybody loves JSON. Analytics does not. Analytics likes rows and columns. And that's my personal view. Because eventually, I don't think anybody will not do pd dot read something. Every analytics code
Yeah.
somewhere ends up into pd dot read something. Every analytics code somewhere ends up into read that and some slicing. So eventually you're making them rows and columns, and you're processing them on rows, because machine learning is typically row optimized. You have to do row optimized conversations. Now, when you are doing a row optimized conversation, schema changes are disasters for you. Imagine you are getting JSON pairs, and suddenly someday somebody decided, hey, let's not send this today. They are very happy to not send it. But if you have relied on a schema driven system, just that missing one single day can screw you over big time. And the worst part is finding it is even more challenging. How
Hmm.
would you find it? First you catch it, and then you convert it into a stable, then you, or actually no, first you have a pub sub where your service catches it, then you have a downstream, then you put it into some sort of a store from where you transpose it, convert it, and make it fit into DDF and all that. So coming back to what you said, data contracts solve this. Simple. So when you have data contracts, you will be your teams would be enabling those conversations that, hey, let's stick to this. Let's not change it. If there's no data, let's agree to a convention. Send me blanks, spaces, or send no data was decided today, go screw yourself. But send me something. Don't miss the packet or don't miss the key. So yeah, I think data contracts could be one of the important things that could help accelerate early adoption of ML and also move it forward to the production.
All right. So I think this is kind of an incomplete one, but so let's complete it off. So I think we had a different set of discussions out there, right? Data contracts can make a huge impact. So you also talked about how analytics can be made simple and faster. But let's talk chunk by chunks. How is analytics going to be made different, and how is modeling of and data going to be made easier? Like not made different, I think made easier in terms of whatever we are trying to build here.
So I think the whole conversation on data contracts are very young, but let's try to understand how the arrows that you have just drawn could be there. Let's say that I am again. Let's go back to the sports example, right? Let's say I have certain data points that I'm trying to send, right? I'm
Mm-hmm.
trying to send in every payload, and then okay, there's also conversations that lies in hard data contracts itself is a new conversation. So let's go back to the
Mm-hmm.
sports example as I was saying. So let's say that in every payload I want to send information about the batsman and the bowler. Okay.
Mm-hmm.
And suddenly there comes in a system which says, okay, I am not gonna be sending you this attribute of the bowler. I'm gonna call it something else, right? Now, what happens is the moment you decide to call it something else, it's okay for you because you are generating the data. But if you go back in your diagram, once it is captured and stored, all previous keys were called something else. And now you have completely new name for which you have either for which either the continuity of the data has been maintained or the name is, well, just completely new, right? It could be a new key, it could be a changed key, it could be a key where the some name shuffling has happened, it could be order shuffling, it could be moving from one array to somewhere else, and all of those. So any or all of those changes could lead to fundamentally breaking of your flow and the pipe. Let's just think of it that way, right? And
Mm-hmm.
as your pipe breaks, as your cleanup operation breaks, your further steps down the line, which is generating analytics and doing modeling, will eventually break. Contracts would help prevent that, and that's pretty much what the conversation is about. But I think it's
All
pretty
right.
early.
So,
This is a topic to pick more into 2024 or something like that, or even later.
hmm.
I don't know how data contracts would become at that time.
All right. So the data cleanliness, of course, is getting disrupted. But if we just look back at whatever you told, communication is not just PubSub. LinkedIn made a dream of coming out with something called as Kafka because they were pissed off by the way PubSub was working. Because they started with their own PubSub model and it was not scaling to the queries that was coming in, the events which were getting captured, a lot of things were happening. So Kafka became one of their mainstream project which they started working. And of course, there is always a fight which goes on in industry who has the biggest Kafka cluster. So now, seeing this as one of the diagrams, like data contracts as one of the, let's forget the fact that there is a data contract here, but let's imagine there was no data contracts. What would have been the process that would have taken us? Like it can be a short five
I
minutes thing
would,
that you can say, so that we can just take
I
another
would,
part two next time.
sure, sure. I would imagine that if you have pub sub in the form of Kafka, you have some events being generated somewhere,
Yeah.
and you are trying to capture multiple different data streams, consolidate, aggregate, and report. Let's say that you have the data being sent from, let's say you're trying to build a weather system, okay, or
Hmm.
the you're trying to build the sports, for example, maybe you're trying to build the batting average of the batsman, right? So you will have some events getting generated, you will have the payload for it coming in through, you'll have a receiving system which will say that, hey, I have received a new event. Any listeners out there, it's going to take that data, hold it into its buffer. You got to make sure that the size of it is less. But yeah, that's pretty much it. The contract part is basically an abstract idea where you are giving the schema more importance, and let's just say you're trying to, how do I define that in this context? uh, so yeah, you could probably think of it this way, that the batsman example which I was giving, I am consistently getting the data, I am constantly getting the feed, the events are getting generated, there is a technology piece which is capturing that, which is what you said, Kafka, and it's holding off the message for some time and then publishing it off to downstream
Publishing.
services. When contracts come in, I think there would be more conversations to have, but not at this point in time. I don't think I have a case study in mind right now that I can think of immediately and give you an example with the chain of thoughts that I'm flowing. Maybe we can have it another time.
Sure. I think whatever I saw over a course of time, as a guy who just saw some sort of a big data application being rigged up, I think it's always about relying on platform more than relying on what is going to be the change over a course of time, because platforms are going to drive the way which we are going to architect. The decision that you make today is not just going to be the one decision that you are going to make tomorrow. I think platform engineering as an platform, as an engineering practice, it's going to evolve within the data engineering. And there's a lot that's happening. Yeah, I think that's true.
So, absolutely. I think platform engineering is one of the most coolest things that's happening right now. I think people are taking out the time and effort to think about how they utilize these cloud services. Previously, it was all about let's be on cloud. Now it's about, hey, now that we have arrived, let's arrive in style. I think that is
Yeah,
what I call platform engineering. And that's where the fun stuff is. That's where the coolness is. Because uh, to me, I say that selecting the what is not a very difficult architecture conversation these days. I think given the amount of reference architectures that the cloud providers publish and the material on the internet, anybody, and I think ChatGPT included, could give a decent architecture. But that's the what, right? The how is the platform engineering. I don't think ChatGPT can give the how. How do you implement a certain technology in a problem is still a human problem to have, is still a human conversation to have. The questions needs to be asked by humans, and human beings need to answer them, and then technology comes in. So platform engineering, I've led teams in the past for platforms, and I think is really cool place to be in specifically. And I think there's another technology which I want to mention is Kubernetes. That's really, really
hmm.
super cool and fun. Awesome. Let's
Sure,
move
sure.
forward.
I think let's move forward. I think it's almost 40 minutes. This is the part one of
Oh
the
yeah,
series. Let's end the series here.
sure.
Or else we can have a day full of conversation, which can be one day full of data engineering.
We could do that if we get enough people. I basically need a constant pool of questions to say I know this, I don't know this.
Yeah,
Other
that's how it
other
is.
otherwise it's I'm thinking and okay, I can't find it. I at least unless somebody gives a pull, it's probably somewhere in the memory, but I can't recall it. So that happens a lot of times.
Sure, sure. I think there is a boot camp that we are just doing from TensorFlow user group Bangalore. I think you are one of the people that you were very interested. Why not just have you? So that was the conversation that we had. So we'll just have you. That's it.
Sure.
Let's join for the boot camp. That's it. Simple as that. So I think, folks, this is the first part of the series. Second part is going to be there either tomorrow or else whenever we are free. We'll just come and have that conversation out there, and we'll just keep going on.
Yep. So should we call it off then?
Let's call it off.
All right, guys. Bye bye. Good night. Have fun. Do subscribe to Vishwas Narayan on his YouTube and Cafe IO on mine. Connect with us again on LinkedIn. Again, his LinkedIn is where you're watching. Mine is Akash Verma. Bye bye.
Bye, folks.